The Pythagorean theorem was created by an intelligent philosopher named Pythagoras. The Pythagorean theorem can be used to find the unknown side of a right triangle, often being the hypotenuse. For example, if two legs of a right triangle are given as 4 units and 6 units, then the hypotenuse, the third and the longest side of the triangle, can be calculated using this formula: a squared plus b squared equals c squared. Where c is the hypotenuse and a or b are the legs, the answer to this example would be around 7.21. Now for the visual proof. To prove the Pythagorean theorem, we will first start with a triangle, which will be labeled A and B. Now we will create two squares, one with the side lengths of A and another with the side lengths of B. So this will be A times A, and this will be B times B. Once we create those squares, we'll put them together side by side, and it'll create a shape that looks like this. Now we will be trying to fit this triangle, inside this shape. So it'll look something like this. So here's the first triangle. Here's the second triangle. These are the same triangles, by the way. I just create duplicates of them here and here. So now we will rotate these triangles. So this one will go like this, and this one will go like this, about these points of rotations. For example, this point here will meet up here, and this point here will meet up right here. Now, if we do that, it looks something like this. What we've fitted here is a larger square. We will call this c squared, or c times c. The square has the dimensions of c times c. So this square is equivalent to the area of the shape we had before, which was a squared plus b squared. Now the Pythagorean theorem states that a squared plus b squared equals c squared. And now we can say that's true because a squared, the first square, which is here, plus b squared, the second squared, is equal to c squared. Forgot to mention that the Pythagorean theorem only works with right triangles. So just giving you a heads up right now. Which is here. Now we can move on to the algebraic proof.
Algebraically speaking, if the area of the whole square equals a plus b parentheses squared, and the area of the total square is c squared, then each of the four triangles have an area of ab over 2. If we add up all four triangles together, they add up to be 4ab over 2, which simplifies to 2ab. Then add the area of the total square with the four triangles total to be c squared plus 2ab. Finally, if we solve the area of the whole square, a plus b parentheses squared, equal to the previously created expression c squared plus 2ab, then it proves the Pythagorean theorem.
From these two proofs of the Pythagorean theorem, we can conclude that the definition of the theorem, which is the sum of the squares of the lengths of the legs, is equal to the square of the length of the hypotenuse, which is a squared plus b squared equals c squared, is true. Ha! You really thought we were done? Well, we're not. We have a quiz. Are you ready? Then let's do it.